And then we can share, and I'll share the desktop. All right. Let me check one more thing. Okay. All right. So yeah, no major announcements. Exam 2 is out. I'll be monitoring the chat as we go through today's presentation. I just wanted to take like 20 or 30 minutes for each section, give or take a few, um, and just kind of do a brief pass through of the sections regarding our exam. And then next week we'll start chapter 2. Okay. So yeah, I'll just choose a few at random until specific questions come up. I think some of these we can actually get through fairly quickly. So I'm gonna kind of do a speed run or a speed trial, see how quickly I can get through these. Okay. So if f of x equals this, evaluate the following. Okay. So what this is saying, basically say f of -2 plus g of -2. If we plug -2 into x, that's going to be 4 plus 4, that's going to be 8. That's going to be a positive 8 ultimately because of that extra negative. 16, 17. So then 17 plus 8, I think it's 26. Let's try 26. Let's try it again. That's going to be 4 plus 4 is 8. That's going to be plus 8 ultimately. No, 2 times 2 is 4 times 2 is 8, yeah. 8 and 8, 16, 17. 17 plus 8, 15, 25. Okay, I think I added one extra. 25. Okay, let's hop back over here. User. Okay, let's go ahead and hopefully, there we go. Okay. So if we plug in -4, 4 times 4, okay, I don't know if I can do this one in my head. I don't really want to write it down, but basically, 4 times 4, let me see. 16 times 4 is 40, plus 24 is 84. So we're going to say 9 minus 84. Nope. 9 plus 84. All right. 84, 94, 93, right? So I think this one is 93. 16 minus, no, plus 8 is 24. Okay, let me write it down. I'm trying to do it all in my head. Trying to be quick with it, but not being successful. Let me write it down. I'm not going to show my notes for this. I'm just going to try to work it out as quickly as I can. Unless someone requests for me to go back over something else. Okay. So this is 1/6. This is question number 2. We got this f of x, x squared minus 2x, g of x is 9 minus x cubed. This is part B. It asks us to do g minus f of -4. Okay, let me at least show. That one is this one. Oh, shoot. Okay. Hopefully I can save myself. Okay, I think we're good. Ouch. Okay, this just means do g of -4 minus f of -4, right? G of -4 means we're going to have 9 minus -4 cubed minus f of -4 is going to be -4 squared minus 2 times -4. Okay. 4 times 4 is 16 times 4 is 40 plus 24 is 64. 64 plus 9 is 64, 74. So I think that's ultimately going to be 73 minus. That's going to be 16 plus 8 is 24. So minus 24. 73, 63, 53. 50, 49. All right. You can use calculators. I'm just trying to crunch the numbers as quickly as I can in my head, and just trying to be quick with it. You don't, anyway, 49. Okay. So if we plug in -1, that's going to be 1 plus 2. 1 plus 2, that's going to be 3. 9 plus 1 is 10. 10 times 3 is 30. Okay. -3. So that's going to be 9 plus 6 is 15. Nope. 9, 27. 27 plus 9, 27, 37, 36. 36 divided by 9 plus 6 is 15. 36 divided by 15. These are at least both divisible by 3. If we divide the top by 3, we'll get what? 12. The bottom by 3, we get 5. Okay, let me just check the chat really quickly. Chat looks good. Okay, let's keep moving. I'm going to skip this one because this one's very similar to what we just did, so I'm going to go to the next one. Okay, f plus g. If we just add these together, we just combine like terms. So I think it's just going to be 2x squared plus 5x minus 6. The domain of each one, right? Both of these are all reals. All reals intersect the all reals is going to be C. Okay. So f minus g. So then we can say negative 2x squared plus 5x minus 6. And same argument as the first one. Again, if I need to go over anything, just let me know. You have to stop me. If you don't stop me, I'll keep going. Multiply these together. If we multiply, let me see, 2 times 5 is going to be 10x to the third. Looks like minus 12x squared. Same argument, so I'm going to go C there. F divided by G, this divided by that. Okay. So we're just going to do 5x minus 6 over 2x squared. Okay. And then everything except 0, because we can't divide by 0, right? When x is 0, that makes the denominator 0, so we have to scrap that one. Okay. I'm going to skip this one. It's similar to the one we just did. Trying to get to ones that are different. Okay. G of f. So first we do f. We want to pass this through g. So let me see. That's the inside function. So we're going to replace all these x's here with f. All right. So first I started by replacing the x with a blank set of parentheses. Into the blank parentheses goes f, which is this. Then I want to simplify. So if we simplify, that'll be 4x squared minus 8. So then ultimately we'll get plus 1. Okay. So then if we plug in 2, 4 times 4 is 16, so that's going to be 17. When we plug in -3, 9 times 4 is 36, so then 37. f of g of -1. Yep, yep, yep. F of g of -1. So if we plug -1 into g, that's going to be 2 minus 1 is 1. We take that 1 and plug it into f. 4 plus 3 is 7. Okay. F of g of -b. So g, so we're going to take f. We're going to replace each x with a blank set of parentheses, plus 9. And then into the blank parentheses goes g, which is 2. But instead of x, we're going to do -b squared minus 6. Okay, then we need to simplify. So -b squared becomes positive b. It's going to be 2b squared like this. If we distribute the 5, this becomes 10. 5 times 6 is 30. So I think it's going to ultimately be a -21. I think that's okay. Let's go with that. Okay. Let f be this, f of 1, so we plug in 1. That's going to be what? -2. Then we plug -2 back into the function. -14, -23. And again, I'm just trying to get through them as quickly as I can, but stop me if I need to go back or go further into detail on any of these. Okay. The functions evaluate f of g and find the domain. Okay. F of g. So the outside function, we have this. The top is 5. The bottom is something plus 1. That something in this case is going to be 5 over x. But to simplify, I'll multiply the top and the bottom by x. So then what's going to happen is this is going to get an x. That x is going to cancel. And this is going to become this. And again, I'm just going quick. If I need to go into details, let me know, and we can write it all the way out. I think it's like this, right? So the domain. The domain of the inside function is everything except 0. The domain of the simplified is everything except -5. So then if we take the intersection of those two sets, it's going to be everything except 0 and -5. So we got to throw out, we can take all rows except 0 and except -5. So -infinity up until -5. Then we're going to say cup -5 to 0. So basically I'm capturing all numbers except -5 and 0. So we're going to say 0 to infinity. Okay. F of g, so g is inside of f. So f is the outside function. That's going to be the square root x minus 4. But then the x in this case is going to be 1 minus 5x. Okay. If we combine like terms, 1 minus 4 is a -3. So it's going to be a -3. We've already captured the 4, so let me get, and we don't need our parentheses anymore. And this is it there. Now for the domain, the inside function is g. That domain is all reals. For the simplified function, we can't take the square root of negative, so this has to be greater than or equal to 0. So if we add, that's going to be 5. Let me write that part out. So this is number 11. I got to reboot this. So this is number 11. I just want to do, this comes from 1.6, question 29. We need for negative 3 minus 5x to be greater than or equal to 0. If we solve, we get negative 3 is greater than or equal to 5x. Divide both sides by 5. Negative 3/5 is greater than or equal to x. Okay. So if the domain of the inside is all reals and the domain of the simplified is x is less than negative 3/5, the intersection of all reals with that less than is going to be just the less than. So then our domain is going to be all numbers less than or equal to negative 3/5. So the far left is negative infinity. The far right is going to be a negative 3/5. And it can be equal to 0, so we're going to use a square bracket. Let me check the chat really quickly. Is somebody in the waiting room? No, it doesn't look like it. I'm gonna. This one is a little bit time consuming. I'm gonna skip it over right now. F of g and then the domain of the composite function. I think we just did one like this. I'm gonna skip this one too. Let's do this one. F of g and the domain, right? G is inside of f, so ultimately we're gonna have the absolute value of x squared minus 5. So if g is the inside function, that domain is all reals. That's simplified. There are no restrictions, right? We have a polynomial and absolute value. There are no restrictions there. So the domain, ultimately, if we all reals intersect all reals, it's going to be all reals. So the inside function could be x plus 1. So our g could be x plus 1, and then I'm going to go c. So the inside function could be, so the inside function is x minus 9. So then the outside function can be 7 divided by x. Okay. The inside could be x cubed minus 3. So g could be x cubed minus 3. And the outside is this one. So let's go d. So I know we did this one. We did this one, so I'm gonna skip this one as well. Okay. So let me hop over to section. I think we could do 1.5 quickly as well. And so I want to say the exam should be similar to all of these. Let me go to 1.5. And I want to hit preview. And let me check OBS because I know sometimes that likes to not work properly. Okay, it looks like it's working. Okay, so this one is about transformations. So for instance, for part A, if we add 4 on the outside, that's going to move it up by 4 units. 4 units up, so that should be C. The second one is going to move it 1 unit down. So that's A. If we multiply the outside by a negative, it's going to flip it vertically, so reflect over the x-axis. If we multiply the inside, B, right? The inside by a negative is going to reflect it over the y. So the basic function here is a reciprocal function, which is 1 over x. Then we stretch it vertically, so we're going to stretch it vertically by multiplying each y by 7. All right, so we multiplied the outside by 7 and did a vertical stretch. The x values stayed the same, but the y values all got multiplied by 7. Okay, so all this is going to be a parabola that we move down by 4. So just like this to plot. Let me see. Yeah, we want to do a vertical shift of -4. That's it. This is a square root function that moved up by 5. I think it's a. A is the only one that does that. Absolute value, instead of going to the left, it goes to the right by 1. So the vertex right here, this one, this is the only one that did that. Okay, this is a parabola. We're going to move it right 1 and up 4. Parabola. I'm just going to click here, and I want to go to the right by 1 and up by 4. And that's it. Okay, so this is going to be a cubic function. We're going to flip it vertically and then move it down by 6. So flip it top to bottom and then move it down by 6. This one, so I'm going to click in the center. And reflect over the x-axis. And then move it down by 6. -6. Okay, so this is a parabola. We have what? 1, 2, 3, 4 transformations altogether. On a parabola. Okay, so it looks like we need to start with the vertex, right? So the coordinates of the vertex are going to be -1, -2. So we're going to go left 1 and down 2. It's going to be the vertex, and then we just need one other point really. So when x is 0, negative, it's going y is going to be -5. Okay. So transformations, we got 1, 2, 3 transformations going on. This says to go right 3, flip vertically, and then down 2. So it can't be C or D. 1, 2. Thinking is A. A looked like it went right 3 and down 2. So this is going to be a step function. We go right 2 and stretch it vertically. So it's not A or B because they didn't get stretched. They got compressed. And then we say we go right 2. This one like it went to the left. This one went to the right. So we're going to go with D. 2 units to the left. So we want to add 2 on the inside. Absolute value of x plus 2. It's upside down, so that means outside by negative. 3 units shifted to the right. So we're going to subtract 3 on the inside, so it's one of these two. And then 7 units up, so it should be C. Okay, equation, okay. So we're going to have this x cubed, x to the power of 3. 4 units left, so that means we need to add 4 on the inside. Stretch vertically by a factor of 2. So here. Reflect it horizontally, so we need to multiply the inside by a negative. And 3 units up. So this says take the original graph and move it up by 4. I'm going to follow the center. Only one that moved up by 4 is D. So if we multiply the inside by a half, you would think that it would shrink horizontally, but remember horizontal is going to be the reverse, so it actually gets stretched by a factor of 2. So the y values stay the same, but all the x values get doubled. I think it's this one. The only one that looks like it was stretched horizontally is A. We subtract 1 on the inside, that moves it to the right by 1. So it looks like A, right? A is the only one that looks like it went to the right by 1. Right 1 compressed vertically by a factor of a half, flip top to bottom. So it has to be either B or D. That moves from what, 2 to 4? I'm gonna go B. Wait a minute. And then it says up 3. Yeah, B definitely went up. Let's go B. So we did this one a couple of times just for the sake of time. I'm gonna skip this one. Daytime hours. I'm gonna say 65 degrees. Overnight is at 54 degrees. So if we subtract 4 on the outside, that's going to move everything down. So the change will lower the temperature by 4 degrees. I think this is the only one that was lowered by 4. If we add 5 on the inside, that's going to move it to the left by 5. So that's going to make everything happen earlier. So everything shifted to the left, right? So then, what is this? So this is at 10. So then it should be to what, like 5. This little corner should be at 5. This is the only one that looked like it did that. It moved everything to the left. Okay, so that wasn't too bad. We were able to get through 1.5 and 1.6, just going as quickly as we can. I didn't really want to keep you much longer than that, okay? So if you don't have any questions, hopefully you've completed your exam, and have a good weekend. Okay, I'll see you guys, I'll see you Monday. Monday.
See.
Have a good weekend.